All right, so remember, we are looking at exponential functions. There we go. Just y equals b to the x, which means that its inverse function will be x equals b to the y, right? Inverse function is x equals b to the y, and in order to solve that for y, we have defined something called a logarithm, so that log base b of x is equal to y. So, for instance, if we have 2 to the x, that means that our inverse function will be log base 2 of x. Okay, if we have 7 to the x, we're looking at log base 7 of x. If we have 10 to the x, we have log base 10. So when we're talking about exponential functions, we input an exponent, we get out a number, right? And so if I say what's f of 2, we're going to say, okay, that is 4 squared, we get 16. With logarithms, on the other hand, we are inputting a number and we are getting out an exponent, all right? So if I say, okay, what's log base 4 of 16, we are going to get out 2 because 4 to the 2 is equal to 16. So we're looking at base to the answer equals the input. In fact, I'm going to write that. Base to the answer equals the input, which of course is what we mean when we say b to the y equals x. Okay, so let's do a couple of these by hand, right? Which means no calculators, right? So we're really answering the question, what exponent should be placed on the base to give the number in the argument? So if we want to find log base 3 of 81, we are thinking, okay, 3 to the what equals 81. And with a little bit of thought, we'll say, oh, well, 81 is 9 times 9, and 9 is 3 squared. So this is 3 squared, which means 3 to the 4th. So there's our answer, right? 4. What power? So log base 2 of 64 really means 2 to the what power equals 64. And we can do real quick, 2, 4, 8, 16, 32, 64. This is the first, second, third, fourth, fifth, sixth power. 2 to the 6th is equal to 64. All right, so log base 9 of 9, that's really asking 9 to the what power equals the input 9. And of course that one is just going to be 1, right? What about log base 4 of 4 to the 3rd? So that is saying 4 to what power equals 4 to the 3rd? And that one we can just look at and we'll go, well, of course, it's 3. So log base 8 of 8 to the 5th, same story. 8 to the what? 8 to the what equals 8 to the 5th. Right, so it's usually going to be easier when you're finding these things by hand. It is almost always, I don't want to say always, but almost always going to be easier to restate this as an exponential. 8 to the what equals 8 to the 5th. We're going to say 5. Log base 4 of 1/4, we're going to say, okay, 4 to the what power equals 1/4. And we've got to remember here that this is going to be a negative power because we've got the 4 in the denominator. It's going to be negative 1, right? 4 to the negative 1 is the same as 1/4. Log base 2 of 1/8, same story, right? These become very repetitive. 2 to the what power equals 1/8. We're going to look at that and say, oh, that's 1 over 2 to the 3rd. So this is going to be negative 3. Log base 5 of 1. 5 to the what power equals 1. And of course, anything to the 0 power equals 1. What about this one? Log base 3 of negative 9. So 3 to the what power equals negative 9. And we're going to say, ooh, it's not real. So, because there is no, I can't raise 3 to any power and get negative 9. So we're going to say it does not exist. And we're going to remember that negative 9 is not in the domain of logarithms anyway. Okay, so that's a good place to break. continue on in the next video.